It's Clive Rocksinger here. Now, I just tried to design a circuit that I'm putting this up on as a post, but this thing had me completely perplexed. What I'm doing is I'm designing my first circuit, a real one, and what it was I bought a Hewlett-Packard printer, which is a genius machine. It was incredibly cheap. I was going to spend $1,000 on one, but it's only doing this. And it printed out for a while, and that's all I can get it to do. And I believe what it is that the cartridges that came with the machine were only probably small ones. And I mean, this is like $70 or something, so it's a darn good printer. That's it there. The Hewlett-Packard 4100. It's a really good machine, but where it really throws you with this is back on the old machines you used to do everything on the machine. With these new ones, or with this new one, you do it all with software. It's all done through here. And so even things like your analytics, like how much ink you've got, and I believe you can do it through here. So this is quite a different machine, but because I couldn't print labels out, what I did was I bought some clear PLA, and I got a reasonably good result, but I couldn't print out characters, and I thought, well, I'll backlight it with an LED. So what I did was I got a power supply. This is 12.5 volt, 2.5 amp. This is killer. Heaps of power, and I put this connection on it. But as you can see, that's a bit fraught with peril, the way I've got that connected there. I needed something to hold that together. So what I did was I designed a thing in Blender that will hold that together. So I forced that together with, it's actually a terminal, and I scrunched it, and I got it to get in there. Now it will be a good connection if I can force those two things together and make them stay together. And so that'll actually have to go into a vise, and I'll probably have to squash that red thing in to make it go in. So this will work, and what I'll do is have backlit characters. And I've made up, well, what did I do with that? I've made a new thing here, which is a base. And this is, which is stupid, this one, because I haven't got it right. But this is a rotating base with weights in it. And I can't pull that off, but which way does that go? I don't know if I can pull it off. Yeah, that slides off that lid, and there's metal weights in there to hold that down. And what you do is you put A, B, C, D, and you sit them, and it's going to have little panels that come out to the left and right. And with A, B, C, D, E, F, G on it, and all that sort of thing, and you can put different extensions on it, and you make the little letters come up at the back of the thing, and so you can put all your pinouts in there so you know what you're doing. I want to make this as simple for myself as I can. And so this is me set up here. Oh God, shut up, Albert. I'll get you in a minute. I'll let you out in a minute. Shut up. Yeah, I couldn't get this math right. And what I'd done was, when I worked the circuit out, I took the current at the power supply, which is at 2.5 amp, and assumed it was current at the supply and calculated all that, and I came out with a wattage of, what was it, 156 volt, I think I came out with. Some bizarre number. Where is it? Voltage at 55 volt and 30 volt and 55 volt. But I come out with these bizarre wattages because I assumed that the current supply was the current at this output pack. It turned out that the current in actual fact is only 367 milliamp. What you've got to do is you get your voltage at your supply, which is a constant in series, and then you count your resistors and count them up in series and add them together, which you came to 34 ohm, and then you work out your current supply. Then you go from there. Now it's fine if you know it. If you do it every day, you just remember it. But I haven't done this for ages. I wrote these formulas, oh God, 10-15 years ago. And it's the first time I've come back to do real testing on it. And I find this very interesting, is that the way you go in is critical. Oh, but shut up, Albert. So the way you go into this circuit, the first thing you've got to do is work out what your current is, calculate your resistance, find out what your voltage, because it's a constant. No, it's not a constant. But you know what your voltage of your power pack is. You find out what your current at your supply is. The voltage is going to fall across each resistor differently. So, I've got to let the cat out. Hang on. You're a bloody nuisance. Shut up. Get lost. So, this is a very interesting calculation. I'm going to backlight the this clear PLA. It's not PLA plus. It's a bit hard to see through, and I thought, well, I'll make the characters out of that and poke them through something, and it'll actually have the ABCD, but it'll be backlit. It'll be lit up behind it. And I thought that should look really cool. So I'm actually designing my first circuit here, and I've got to make sure that's a more profound connection. You can actually buy terminals for that, but I'm out in the bush. It's a 25-mile drive to go into town, and $15 worth of fuel. So I'm designing something at home that'll do this, and this is just temporary. I'll get this up working, and I'll use this for quite a while before I have to go to the next stage. But that should work, and I've got it making up at the moment. I think it's going to take 3 hours to make that. Yeah, that surprised me. I got it all wrong. I thought, oh no, I got all the math wrong. It was the way I went in. You got to work out your current in your circuit first, and then you can work all the stuff out and it makes sense. So Clive Rocksinger over and out, and I'll put this post up with all the math and that with it too. It's very interesting when you see how to work this stuff out, because you'd be surprised how many people have fallen into that trap. How would you know to check the current first? It says the current on the unit is 2.5 amp. Well, you think, oh, it's current supply. Well, it's not. When you go into practical, totally different ball game. Alright, Clive Rocksinger over and out.